The scientific revolution is roughly between 1540 and 1690. The scientific revolution fundamentally challenged the long-held beliefs of church doctrine and attempted to answer the questions such as why are we here? Is the earth the centre of the universe? And what is a rainbow? For our period of study, two names bookend the period: Francis Bacon and Isaac Newton, and both names will have a fundamental impact on the workings of the Royal Society in the advancement of science at the end of the 17th century, laying the foundations of the technological advancements of the 18th century and the Industrial Revolution. The intention of this lecture is for you to reach a judgment on how drastic the scientific and philosophical changes between 1625 and 1688 were. In doing so, we'll explore the following. Knowledge-wise, explain the impacts of Francis Bacon, Isaac Newton, and the Royal Society. Skills-wise, be able to assign criteria for the assessment of their impact. And then behaviourally, evaluate the criteria to reach a substantiated judgment. In today's world, the ideas of Francis Bacon are nothing radical, nothing abnormal. They are the fundamental principles of the scientific method. However, we have to remember that at one stage every norm was new, and therefore in many cases a radical shift from the old. To understand what Bacon's ideas were, we need to contextualise him. Bacon was well accomplished in the fields of philosophy, law and politics, which is why he was both Attorney General and Lord Chancellor for King James I. He was writing and working at the time of great conflict in religion, and his ideas about experimentation and rationality were unheard of in a society which was heavily influenced by the Church. But why was the influence of the Church such a barrier to scientific advancement? Let us consider the questions the scientific revolution looked to answer. Firstly, why are we here? The answer: God's master plan. Secondly, is the earth the centre of the universe? Answer: yes, because we are God's creation. And thirdly, what is a rainbow? Answer: a sign from God. It is clear then that any questioning of the reasons for existence threatened the fabric of belief in a divinely ordered universe. Therefore, Bacon's ideas were truly radical and can be seen to challenge the power of God. Bacon's scientific method is what he is most remembered for, and can be broken down to three key elements. Firstly, he believed that scientific discovery is best aided by the accumulation of as much data as possible. It is not just good enough to do it once. Repeat the experiment to ensure the results. Secondly, you must reject any preconceived theories or conclusions about the subject matter. This is the element which truly challenged the power of the Church. God's master plan is the biggest preconceived idea at the time. And finally, you must, not someone else, methodically and meticulously observe the experiment to ensure you understand the process and outcome. It is these key elements which make up the scientific method of Francis Bacon, and therefore lay the foundation of the scientific enlightenment at the end of the 17th century. When Bacon died in 1626, others attempted to apply his thinking. However, it took the changes in social attitudes of the 1640s for his ideas to be truly embraced, certainly by such individuals as John Locke. Locke, by observing society, believed people are born naturally good, with a tabula rasa, a blank slate, and do not have innate ideas. All knowledge is learnt by experience, challenging the Socratic approach of innate knowledge, which could be unlocked by questioning. Lord Falkland, who died in 1643 during the Civil War, applied to religion. Falkland's group came to the conclusion that toleration was the best idea due to the contradictions within the Bible. However, his biggest influence was for the Royal Society established after the Restoration, where Bacon was cited in meetings for his guiding genius in the scientific method. These simple ideas of Bacon, the promotion of experiment and rationality spread to other schools of thought, such as the study of society, philosophy, and history, and had a fundamental impact on the development of the Western world. Sir Isaac Newton is one of the most influential scientists in history. He changed the face of scientific thinking then and still holds the prestige as one of the world's finest minds, with most of his work remaining relatively unaltered to this day. Newton is famed for giving the world calculus in his work on motion. We also have the theory of gravity and the impact of gravitational pull on the Earth and other celestial objects, plus his work on optics and light, explaining why rainbows exist. Newton was elected in 1703 as the 12th President of the Royal Society, a post he held until his death in 1727. Nevertheless, Newton was well aware of the fact that his work was only possible because of the thinkers before him. Newton said in 1675, "If I have seen further, it is by standing on the shoulders of giants." For Newton, these giants were Kepler and his laws of planetary motion, the work of Galileo and his telescopes in understanding the movement of heavenly bodies. What Newton's work represents is the long process of theory and discovery over 100 years, and Newton's Principia from 1687 is the break with the Middle Ages and the embracing of the modern age of science. The Royal Society had in some shape or form existed since the 1640s as the Invisible College, where a group of natural philosophers shared an interest in experimental investigation. It was, however, the Restoration which created a political climate for the formation of a more formal organisation. This is mostly due to the keen interest of Charles II in science. In November 1660, Christopher Wren, the architect of both St Paul's Cathedral and the Greenwich Observatory, proposed the Royal Society. It was established by Royal Charter in 1662. The aims of the Society are clear in this source from 1687, which states, "The design of the Royal Society is, in brief, to make faithful records of all works of nature or of art which can come within their reach, so that the present age and posterity may be able to put a mark on the errors which have been strengthened by long prescription, to restore the truths that have been neglected, to push on those which are already known to more various uses, to make the way more passable to what remains unrevealed." The Society was to return to the research, the classicists, and answer the questions as to why we are here, work which had been forbidden by the Church up to this point. The Royal Society can boast some rather impressive membership, including John Locke and Samuel Pepys. Before 1684, the Society's work was varied, including investigations into the English language, for example. Afterwards, science was its work, attracting some of the greatest minds over both Oxford and Cambridge, including religious nonconformists who saw the Society as the best way to push the boundaries of science. The importance of the Society is its use as a channel to air discoveries and share them on the international stage in the Society's journal published since 1665. For example, in 1661, Marcello Mapighi wrote to the Society with his observation on the capillary action in the lungs of frogs, which gave Harvey the missing link in his theory of blood circulation. This model of a scientific society was copied on the continent, France in 1666 and Prussia in 1700. The Royal Society gave a boost to the ever-increasing belief that humans could progress without divine intervention, and therefore contributed to the aims of the Enlightenment. By 1688, the Age of Reason, which had started in the 1650s, had truly begun. Topic 3 and 4 ask you to consider changes over a longer term period, in this case 1625 to 1688. With regards to society, its structure was not that dissimilar to 1688 to that of 1625, and attitudes will not have been that different for most people. The poor were still poor. Although they had received limited help from the Elizabethan poor laws, The increase in population change and the changes in town and country put huge pressures on society that the benefits of these changes were not always felt. The changes in society did not affect the majority of landless peasants whose existence lay in the hands of landowners. Religious nonconformity was established in law after the Restoration, which restricted the groups who favoured a fair and more equal society. However, it is clear the seeds of change were planted during the Civil War and interregnum, which will ensure many of these religious groups survived. And women in society had not shifted drastically after the events of the Civil War and Republican years. However, near equal status was available in groups such as the Quakers. When discussing these changes between 1625 and 1688, it is important to remember the whole population of Britain and try not to generalise. And if you do, make it clear by saying in general. Also, though these things may not have a massive impact at the time of happening, their impact can be measured by their later achievements. For example, the ideas of Locke in the 17th century influenced the development of liberal government in the 18th and 19th century. Also, the scientific method spills over into schools of thought in the following centuries, and therefore the desire to question accepted systems and traditions is one of the major achievements of the 17th century. In answering questions, you need to develop the factors and criteria by which you will judge the question. Consider when, where, why, who, and how in exploring the inquiry. It is your job as an amateur historian to discuss the question posed and using the factors and criteria you have selected to reach a substantiated conclusion. It is therefore important to remember there is no one correct answer, just your argument, using evidence to reach a fully supported judgment. The intention of this lecture was for you to reach a judgment on how drastic the scientific and philosophical changes between 1625 and 1688 were. In doing so, we explored the following. Knowledge-wise, explain the impacts of Francis Bacon, Isaac Newton, and the Royal Society. In the associated material, you will now need to develop, skills-wise, the assignment of criteria for the assessment of their impact, and behaviourally, evaluate the criteria to reach a substantiated judgment. Now complete the associated material.